Entire cities are rising from the desert. Billions are being spent at a pace never seen before. And Nevada is becoming one of the most aggressively transformed states in America. These megaprojects are pushing the limits of engineering and rewriting what's possible in urban design. Today, we'll go through Nevada's megaprojects under construction in 2025 and why the world is racing to catch up. The Las Vegas Athletics MLB Ballpark is currently under construction and is set to become one of the most transformative stadium projects in professional baseball. Located on the southern end of the Las Vegas Strip, this highly anticipated venue will be the future home of the Athletics franchise, marking the team's relocation from Oakland to Las Vegas after more than half a century in the Bay Area. Construction began following the demolition of the Tropicana Hotel, which previously occupied the site. The stadium is being built on a roughly 9-acre plot at a prime location, surrounded by resorts, casinos, and world-class entertainment. Once completed, the ballpark will seat approximately 30,000 fans, making it the smallest stadium in Major League Baseball by capacity. But this compact scale is by design, aimed at creating an intimate, high-energy atmosphere that enhances the overall fan experience. Architecturally, the stadium is expected to blend the flair of Las Vegas with the functionality of a modern ballpark. A retractable roof is a central feature of the design, providing protection from the intense desert heat while allowing the venue to open up during cooler months. This roof structure is crucial in ensuring year-round usability for not just baseball games, but concerts, events, and other community functions. The construction process includes extensive excavation and foundation work to support the roof's massive spans and retractable components. Deep concrete piles and reinforced structural columns will anchor the stadium, while a steel superstructure will form the skeleton of the roof system. Modern HVAC systems, energy-efficient lighting, and sustainable materials are being integrated into the build, aligning with current standards for environmental responsibility. Inside, fans can expect premium seating options, high-end suites, and immersive digital experiences. The lower bowl will be steeply pitched to bring spectators closer to the field, while concourses are being designed with open views of the playing surface and the strip skyline beyond. When completed, the Las Vegas Athletics Ballpark will not only reshape the team's future, but also elevate Las Vegas as a major league sports hub. The project is targeting an opening for the 2028 MLB season, and until then, the Athletics will play interim home games at various locations as construction continues. The M Resort expansion is a significant development in Henderson, Nevada, reinforcing the area's rapid growth and its increasing importance as a hospitality and entertainment destination just south of the Las Vegas Strip. Located near the junction of Interstate 15 and St. Rose Parkway, the M Resort has long been a local favorite, known for its upscale atmosphere, expansive gaming floor, and panoramic views of the Las Vegas skyline. Now, with a major expansion currently underway, the property is stepping into a new era of luxury and capacity. This expansion, led by Penn Entertainment, is a $206 million project that will nearly double the size of the resort. One of the key features of the build is a second hotel tower that will add over 370 guest rooms and suites to the property, bringing the total room count to more than 750. This addition is being constructed on the south end of the existing resort, carefully integrated into the current footprint without disrupting ongoing operations. The structural design of the tower involves reinforced concrete core walls for lateral stability, along with post-tension concrete slabs to maintain open floor plans and minimize structural bulk. The expanded hotel capacity is being complemented by new amenities, including additional meeting and convention space, expanded dining options, and upgraded pool and spa facilities. There's a clear emphasis on catering not just to tourists, but also to local residents and business travelers. A new rooftop lounge is planned as part of the tower, offering sweeping views of the surrounding desert and city skyline. From a construction perspective, logistics are a key challenge. The project is being built while the resort remains fully operational, requiring careful scheduling, noise management, and phased site access. Crews are working in tight coordination with resort operations to limit disruption to guests and casino traffic. This has led to the use of modular construction techniques for certain interior elements, speeding up installation timelines and maintaining quality control. Sustainability has also been a point of focus. The expansion includes energy-efficient glazing, low-flow plumbing fixtures, and LED lighting systems, aiming for reduced water and power consumption, especially critical in the Nevada desert environment. Once completed, the expanded M Resort will serve not only as a luxury getaway, but also as a key anchor for the growing Henderson corridor, supporting local events, conventions, and regional tourism with a more robust, full-service offering. The Carlin Tunnel Rehabilitation Project is a complex and technically demanding upgrade of one of Nevada's most vital highway structures. Located on Interstate 80 just west of Carlin, the twin tunnels allow traffic to bypass steep terrain along the Humboldt River corridor. Built in the 1960s, the tunnels have endured decades of continuous use by heavy freight traffic, and the rehabilitation now underway is essential to preserve their structural integrity, improve safety, and meet modern engineering standards. Construction begins with detailed structural assessments, including ground-penetrating radar and 3D laser scanning to detect voids, delamination, and reinforcement exposure within the tunnel linings. These assessments guide the scope of demolition and repair. Sections of the shotcrete lining that show extensive cracking or corrosion-related damage are removed using robotic hydrodemolition systems. This method allows precise removal of deteriorated material without damaging the sound concrete or embedded reinforcement. Once exposed, corroded rebar is cleaned and, if necessary, supplemented with new steel dowels epoxied into place. Relining the tunnels involves both conventional cast-in-place concrete and new fiber-reinforced shotcrete, applied in multiple layers for added durability and crack resistance. The new linings are designed to improve both structural load-carrying capacity and water resistance. A critical part of the work includes the installation of waterproofing membranes behind the lining, flexible polymer sheets heat welded to form a continuous barrier against groundwater intrusion. Ventilation and fire safety are another major focus. New axial jet fans are being installed along the tunnel ceiling, replacing outdated ventilation systems. These fans are supported by galvanized steel brackets anchored into the tunnel crown and tied into a new fire life safety control system. Fire-rated cable trays and thermal protection panels are integrated along the walls, supporting improved emergency response and survivability during vehicle fires. Electrical and lighting systems are completely overhauled. Old sodium-based lighting is being replaced with dimmable LED fixtures that adapt to ambient light at the tunnel entrance and interior. These lights are wired into programmable logic controllers that monitor power usage, maintenance needs, and allow for emergency override during incidents. Much of the work must be performed during nightly closures, with strict time limits to reopen the highway each morning. This requires meticulous scheduling, rapid concrete curing methods, and phased material delivery. Crews work within confined conditions, often with reduced ventilation and strict safety protocols. Despite the challenges, the upgraded tunnels will significantly enhance travel safety, reduce long-term maintenance, and ensure the I-80 corridor remains reliable for decades to come. The Laughlin Bullhead City Bridge is a major infrastructure project designed to improve regional mobility, reduce congestion, and foster economic development along the Colorado River, connecting Laughlin Nevada, and Bullhead City, Arizona. While these two communities are physically close, separated only by the river, their connectivity has historically been limited to the existing Laughlin Bridge to the north, which has struggled to accommodate growing traffic volumes, particularly during peak tourism periods. The new bridge is currently under construction approximately 3.5 miles south of the existing crossing. It is designed as a 4-lane structure, 2 lanes in each direction, with wide shoulders and pedestrian access. The bridge is being built using a multi-span concrete girder design supported by deep pile foundations. These piles are driven into the riverbanks and beneath the channel bed using large vibratory and impact hammers to ensure resistance to both vertical loads and lateral river forces. Soil conditions along the Colorado River consist of sandy silts and gravel layers, requiring piles to be driven to depths exceeding 80 feet in some locations for adequate bearing capacity. The superstructure consists of precast, pre-stressed concrete eye girders, lifted into place by heavy lift cranes mounted on floating barges and temporary trestles. These girders span between cast-in-place, reinforced concrete piers, which are constructed using cofferdams, temporary enclosures that allow work to occur in dry conditions below the waterline. Each pier is reinforced with epoxy-coated rebar to resist corrosion from constant water exposure and is formed using custom steel formwork to maintain precise alignment during concrete placement. A significant challenge during construction has been managing the river's flow, especially during seasonal snowmelt or upstream water releases from dams. River traffic is also maintained throughout the build, so construction zones are cordoned off with floating barriers and marine safety patrols to prevent accidents. The deck of the bridge will be formed using stay-in-place metal forms over the girders, followed by high-performance concrete pours that are carefully timed to prevent thermal cracking. Expansion joints and seismic bearings are integrated into the design to accommodate temperature fluctuations and potential seismic activity in the region. Once completed, the bridge will not only reduce travel time between the two cities, but also serve as a critical evacuation and emergency route, a redundancy that's long been needed in the area. The bridge is expected to open to traffic by 2026, unlocking new development potential on both sides of the river and enhancing regional connectivity across state lines. The Hoover Dam Spillway Rehabilitation is a technically intricate project aimed at restoring the full operational integrity of one of the most iconic and historically significant hydraulic structures in the United States. While Hoover Dam itself is a marvel of 20th century engineering, its 2 massive spillways, located on the Arizona and Nevada sides, are equally critical, designed to safely bypass excess floodwaters around the dam structure. Though rarely used, these spillways must remain fully operational in case of extreme hydrological events, and after decades of weathering and sediment abrasion, they are undergoing major rehabilitation to ensure long-term safety and functionality. Each spillway consists of an intake structure, vertical shaft, a 600-foot-long tunnel through the canyon walls, and a stilling basin that dissipates the energy of the discharged water before it returns to the Colorado River downstream. Over time, inspection reports revealed issues such as concrete erosion, cracking, joint degradation, and rebar exposure, especially in areas where high-velocity flow and cavitation forces can cause intense physical wear. The rehabilitation process begins with full dewatering and isolation of the spillway tunnels. This involves deploying temporary bulkheads and cofferdams to block any potential flow and ensure a safe working environment. Crews use rope access and custom-built gantries to inspect and reach difficult areas within the vertical shaft and curved tunnel sections, where traditional scaffolding is not feasible. Non-destructive testing, laser scanning, and drone-based LiDAR mapping provide high-resolution data on existing structural conditions. Concrete removal is targeted and surgical. Hydrodemolition robots are used to strip away deteriorated concrete without damaging the surrounding material. Once surfaces are prepared, new concrete is applied using both cast-in-place techniques and dry mix shotcrete, depending on tunnel geometry and accessibility. In high-wear areas, high-performance fiber-reinforced concrete is used to increase abrasion resistance and extend service life. All new concrete is cured using internal cooling lines and temperature sensors to prevent thermal cracking, which is a major risk in mass concrete repair operations. Another crucial upgrade is the installation of modern energy dissipation features in the stilling basins, such as improved baffle blocks and flow deflectors. These elements are reconstructed using stainless steel reinforcement cages and concrete mixers with high sulfate resistance to cope with the river's aggressive water chemistry. Water stops and modern expansion joint systems are added to accommodate thermal movement and eliminate leakage through structural joints. Electrical and instrumentation systems are also modernized. Remote monitoring sensors are embedded into the spillway structures to track flow conditions, temperature, vibration, and potential seepage in real time. These systems feed into the dam's central control room, where operators can make fast, data-driven decisions during flood events. The rehabilitation also includes seismic retrofits to ensure the spillways can withstand potential earthquakes without compromising their hydraulic performance. This includes strengthening of concrete walls, installation of shear keys, and upgrading tunnel linings with sprayed fiber-reinforced polymer layers in select zones. The Interstate 11 extension is one of the most ambitious highway infrastructure projects in the southwestern United States, aimed at transforming regional connectivity between Phoenix, Las Vegas, and eventually northward to Reno and southward to Mexico. Currently, I-11 officially exists as a 22-mile segment between Henderson and Boulder City in Nevada, bypassing the once congested route around the Hoover Dam. The extension project now underway will stretch the highway both north and south, creating a new backbone corridor for freight, tourism, and economic growth across the desert Southwest. The northern extension will eventually carry I-11 from Boulder City through the Las Vegas Valley, then northwest toward Reno. The first phase of this northern extension involves upgrading existing portions of US 95, transforming the corridor into full interstate standards with limited access, added lanes, interchanges, and elevated overpasses. To bring the highway up to federal standards, median widths are being expanded to accommodate crash barriers and future widening, while horizontal curves are being softened to meet the design speed requirements of 70 miles per hour or more. Construction crews are undertaking extensive earthworks, including rock blasting through desert terrain and massive grading operations to cut and fill along undulating topography. In many sections, engineered embankments are built using mechanically stabilized earth walls with geosynthetic reinforcement to control settlement and reduce the overall footprint. Culverts and drainage channels are also being expanded to handle flash flooding, which is a major concern in the arid and erosion-prone environment of southern Nevada. Meanwhile, the southern extension of I-11 toward Phoenix is still in planning and environmental review phases, but is expected to diverge from US 93 and connect with Interstate 10 near Buckeye, Arizona. Multiple route alternatives have been proposed, with each requiring new right-of-way acquisitions, extensive NEPA environmental studies, and coordination between federal, state, and tribal agencies. Challenges include routing through sensitive desert habitats, dealing with limited water availability for construction, and integrating with existing state highways while minimizing disruption to local communities. A critical component of the I-11 extension involves advanced bridge construction techniques. Grade-separated interchanges are being built with precast bridge girders and accelerated bridge construction methods to limit closures and reduce overall build time. Many of these structures are supported on drilled shafts, extending deep into desert soils to avoid liquefiable layers and support heavy traffic loads, particularly from freight carriers. Another key design feature is the inclusion of smart transportation infrastructure. The extended corridor will feature fiber optic backbones, vehicle detection systems, and dynamic message signs integrated with regional traffic management centers. These systems will improve traffic flow, support autonomous vehicle trials, and provide critical data for long-term infrastructure planning. Once complete, the I-11 extension will be a game changer for regional logistics and trade, providing a modern, high-capacity link between two of the largest metropolitan areas in the Southwest that are currently not connected by an interstate. It will also relieve pressure from I-15 and I-10, offer redundancy during emergency situations, and stimulate development in long-overlooked areas of Nevada and Arizona. Durango Station Resort is a major hospitality and gaming development currently under construction in the Southwest Valley of Las Vegas, marking the first all-new resort property in the region in over a decade. Developed by Station Casinos, the project is part of a broader expansion strategy targeting the booming residential and commercial growth in the western part of the Las Vegas Valley, away from the traditional Strip corridor. Once completed, Durango Station will offer a full suite of entertainment, dining, and lodging amenities tailored primarily to local residents, but with the scale and finish of a premium destination resort. The initial phase of construction focuses on a 15-story hotel tower that will offer approximately 200 guest rooms and suites. Structurally, the tower is a concrete-framed building with post-tensioned floor slabs for reduced structural depth and optimized vertical space. Shear walls and reinforced cores provide lateral stability, critical in this seismic zone. The tower is topped with a lightweight roof structure that supports mechanical equipment and solar arrays, part of the resort's strategy to improve energy efficiency. Adjacent to the hotel is a 70,000 square foot casino floor, constructed using wide-span structural steel framing to create an open, column-free interior. This layout accommodates flexible gaming configurations and large-scale electronic display systems, including an LED ceiling that immerses guests in a dynamic digital environment. The casino's mechanical systems are zoned to manage heavy cooling demands in different gaming areas, using high-efficiency chillers and displacement ventilation to maintain comfort in the desert climate. Surrounding the gaming floor, a curated collection of high-end restaurants, lounges, and retail spaces are arranged along indoor promenades and outdoor plazas. These commercial spaces are framed with a mix of steel and concrete, depending on location and load demands, and are finished with custom facade systems that reflect a modern desert aesthetic. Think warm stone, wood textures, and integrated landscape elements. Extensive canopies and overhangs are used for shading, with structural steel cantilevers extending out from the main frame and finished with aluminum cladding and perforated panels. A central feature of Durango Station is its resort-style pool complex, which is elevated above grade and designed with a multi-level terrace system. Cast-in-place concrete retaining walls and deep pile foundations support these terraces, which will host cabanas, event spaces, and water features. The pool deck is designed using slip-resistant, high-albedo materials to reduce heat gain and includes integrated lighting and drainage systems to handle both ambiance and monsoon season runoff. Parking is provided via a multi-story garage with integrated pedestrian bridges to the main resort. The structure uses precast concrete panels and double T-beams for speed of construction and long-term durability in the arid climate. Electric vehicle charging stations, bike racks, and rideshare staging areas are incorporated to support modern mobility trends. Once complete, Durango Station Resort will serve as a high-end local destination that blends resort-style amenities with neighborhood accessibility, expanding the station casino's portfolio while responding directly to the lifestyle of the growing West Las Vegas community. Its design and construction reflect a forward-thinking approach that balances luxury, efficiency, and long-term sustainability. The Summit Club expansion is a high-profile extension of one of the most exclusive residential developments in the Las Vegas Valley. Located in the affluent area of Summerlin, nestled between Red Rock Canyon and the Las Vegas Strip, the Summit Club is a private, ultra-luxury golf and lifestyle community developed by Discovery Land Company in partnership with Howard Hughes Corporation. Known for its world-class amenities, custom estates, and privacy-focused design, the current expansion aims to increase both residential offerings and lifestyle infrastructure, all while preserving the exclusivity and low-density layout that define the club's identity. Construction within the expansion is unfolding across multiple phases. One of the primary components involves the addition of custom home sites on newly graded hillsides west of the existing community. These lots are carefully integrated into the desert terrain using a combination of cut and fill grading techniques that preserve sightlines and minimize visual disruption to the natural surroundings. Civil crews are installing subterranean utilities, including water, sewer, fiber optic internet, and natural gas, routed through a trench and backfill system designed to protect desert vegetation and sensitive rock formations. The expansion also includes new luxury villas and semi-custom homes that are being constructed using a mix of post-tensioned slab-on-grade foundations and wood or light-gauge steel framing. These residences follow strict architectural guidelines that reflect modern desert design, flat roofs, natural materials, and extensive use of glass to maximize views of the Red Rock Mountains. High-performance insulation, low-E windows, and solar panel-ready rooftops are standard, aligning with the community's emphasis on energy efficiency and sustainability. A key part of the expansion is the enhancement of the community's lifestyle infrastructure. New amenities under construction include an expanded wellness center, additional dining venues, and family-focused recreational facilities. The wellness center is being built with a steel moment frame system for seismic resistance and large open spans, which allow for multi-purpose fitness studios, treatment rooms, and spa areas. Custom mechanical systems are being installed to provide precision climate control and air purification throughout the facility. Roads within the expansion are being constructed with permeable pavers and bioswales for improved stormwater management, a critical consideration given the flood-prone nature of the Mojave Desert. Landscaping is entirely drought-tolerant, using native plant species, drip irrigation, and strategic berming to blend development into the natural surroundings. Security and privacy remain top priorities. All new access points are gated with advanced surveillance systems and fiber-connected monitoring stations. The expansion has also been designed with underground service corridors for maintenance access, keeping utility and service functions out of sight to preserve the club's clean, natural aesthetic. Ultimately, the Summit Club expansion reflects the evolving demand for ultra-luxury desert living in Las Vegas. It's not just about building more homes, it's about deepening the lifestyle experience for one of the most exclusive private communities in the Western US, all while balancing environmental sensitivity with architectural refinement. The Harry Reid International Airport modernization is a sweeping, multi-phase project aimed at upgrading critical infrastructure, expanding capacity, and transforming the passenger experience at Nevada's busiest airport. Formerly known as McCarran International, this airport is the primary gateway to Las Vegas and routinely handles more than 50 million passengers annually. With travel demand surging and regional growth accelerating, the modernization initiative is both a necessary response to current pressure and a long-term investment in the airport's role as a global transportation hub. One of the central components of the modernization is the renovation and expansion of Terminal 1, which originally opened in the 1960s. The work here involves structural retrofits to the terminal's seismic systems, installation of energy-efficient HVAC units, and a complete overhaul of interior finishes. Crews are carefully sequencing demolition and reconstruction activities to allow the terminal to remain operational throughout construction. Behind the scenes, mechanical rooms are being reconfigured with modern chillers and variable air volume systems, supported by upgraded electrical switchgear and redundant backup power systems to enhance reliability. Another key element is the expansion of the baggage handling systems. The airport is integrating high-speed, RFID-enabled baggage screening and sorting systems beneath both Terminals 1 and 3. This requires deep excavation within active operational zones, supported by temporary shoring walls and precise utility rerouting. Advanced modeling using BIM is guiding coordination between trades, ensuring that conveyors, ductwork, and structural elements are installed without costly conflicts or delays. Airside, the modernization includes significant upgrades to taxiways and aprons. Runway surfaces are being repaved using high-performance asphalt mixes engineered to withstand Las Vegas's extreme temperature fluctuations and heavy jet traffic. Simultaneously, new LED airfield lighting systems are being embedded into pavement joints and tied into a centralized control network that enhances night visibility and reduces energy use. Portions of the ramp and descing areas are being reconstructed with reinforced concrete, designed to accommodate the increased weight of wide-body aircraft serving transcontinental and international routes. Terminal 3, which opened in 2012, is also receiving upgrades, not structural, but technological and experiential. Digital signage, biometric boarding systems, and touchless check-in kiosks are being installed across gates and concourses. A new centralized command center is being constructed within the terminal's core, integrating data from security, fire, maintenance, and passenger tracking systems for real-time operational control. Parking and ground access are being rethought entirely. A multi-level smart parking garage is under construction with embedded license plate recognition, EV charging stations, and wayfinding apps that guide drivers to open spots. Meanwhile, new dedicated zones for rideshare, transit, and autonomous vehicle staging are being built on the east side of the campus, supported by realigned access roads and traffic signal upgrades to reduce congestion at curbside drop-off points.